All right, so let's start section 4 of unit 6. We're going to be doing absolute value functions. We're going to be graphing them. And really all you need to do is be able to plug it into a calculator if you don't know what an absolute value is. But an absolute value is going to always be a positive. Even if it's of a negative number, the absolute value is a positive. Okay? So the first one we're going to look at is on the bottom of page 10. All right, so we have f of x is equal to the absolute value of x. Well, on our chart, we're given our x values. Now, you may have to make a chart where you make your own table, but on this one, it's given to us. So we're just going to plug that value in for x. So f of x is equal to the absolute value of negative 4. If you put that in a calculator, you're going to get 4. The next one, absolute value of negative 3 is 3. Absolute value of negative 2 is 2. Negative 1 is 1. Of 0 is 0. Of 1 is 1. Of 2 is 2. Absolute value of 3 is 3. And absolute value of 4 is 4. So you can see it's the same values. The only difference is these are negatives, but the absolute value is going to be a positive. These are all positives, and the absolute value is still a positive. Okay? Now we just need to plot our ordered pairs. So negative 4, 4. So go over negative 4. So x, you're always going to go left or right, and y, you're always going to go up or down. Okay? So over negative 4, up 4. So right there. Next one, negative 3, 3. Negative 2, 2. Negative 1, 1. 0, 0. All right, now at 1, we're going to go up 1. 2, 2. 3, 3. 4, 4. If you was to do 5 and so on, you're still going to keep going. Now, go ahead and sketch your graph. And these will go on forever. So go ahead and put your arrows at the end. And there you go. Now, I want you to look at this. Anytime you draw an absolute function, or you graph an absolute function, it is going to be in the shape of a V. Okay? All right, next page. So we have our parent function, which is what we just graphed. It should start, our vertex is going to be at 0, 0. So the point of the V is our vertex, and it's at 0, 0. So that is our parent function. One thing that we need to do right here is we need to move these arrows over. So on your paper, you may need to do that just because they're not lined up right. But so whenever the transformation happens, whenever we have a whole function, and I'm just going to let you look at, if I just put something in here, we'll have, if you look at the bottom of your page, this is going to be a 2, this is an x, this is a 3, and this is a negative 1. Okay, so that's what that value would be on that graph, on the second graph on this page. But what do those mean? What does that do to my graph? Okay? So if you have a negative out front, it's going to flip upside down. So instead of looking like a V, it's going to look like this. Anytime you have a negative out front, it's going to look like that. Okay? Now, for the A, so number out front, it's going to stretch or shrink your graph. So instead of looking like that parent function that we had to begin with, it may look something like this, be open more, or it may be closed in more, like that. So I'm going to erase this just so you don't get confused. But it's going to make my graph look like it's closer together or further apart. Okay? Now, if I have something on the inside of the absolute sign with x, for instance, even if I have something in parentheses, and we've talked about this before, so it should refresh your memory once I say it. But if it's on the inside, it's going to move my graph left or right. And it's going to read the opposite of what it says. So it reads opposite. So in other words, if I have x plus 3, I'm going to move negative 3. I'm going to subtract 3. So I'm going to move to the left. If I have x minus 3, I'm going to move to the right. All right? So if you need to know that, put this little note here. If it is a negative number, it moves right. If it is a positive number, it moves left. Because we talked about our number, or it always needs to be x minus. So that sign, if it's on the inside, it's going to change it. But this is only for inside, okay? Only for inside. All right, the last one, when we have a number on the outside, it's going to move our graph up or down. And it's going to read the way it is. So it reads exact. So if it is a positive one, it's going to move it up. If it's a negative one, it's going to move it down. Okay? So for the outside, you want to make a note right here somewhere. For the outside, the number, if it's a negative number, it moves down. If it's a positive number, it moves up. Okay? So that's what that does. Okay? That's how our graph is transformed. So if we look at this first graph right here, if we had f of x is equal to the absolute value of x, that's what we graph first. But this number right here is going to cause our graph to move. It's a negative 1, so it's going to move right. And I forgot to see it there. It is going to move right. So move right, 1. On the outside, it's a positive number, so it's going to move up 3. All right? Let me erase this little blue arrow so that way you're not getting confused. So this is going to cause us to move right, 1, and this is going to cause us to move up 3. Now, you can go ahead and make your chart, and on this one, I just kind of, because our chart is, or our graph is negative 10 to 10, I just started with 10 or negative 10 and did every other number. So you can do the same one I do, or you can do a different one. It doesn't matter. But, so we have x and we have y. Negative 10, 8, 6, 4, 2, 0, 2, 4, 6, 8, and 10. You should have room on your paper as long as you write kind of small. But just take your calculator and plug that in. Okay? We're going to get 13, 9, 5, 1, 1, 5, 9, 13, 17, 21. If you did the 10, it's 25. All right, one thing that I want you to notice is from here to here, these numbers are positive, although my x is negative. And right here, I start repeating, and my numbers repeat, and they'll continue on forever. Now, if I was to put negative 12 in there, I'm going to get 17 because it makes the V. All right? So go ahead and let's plot these points. At negative 10, it's 13. We can't get negative 10 on our chart because it only goes up to 10. Negative 8 is 9. Negative 6 is 5. All right, so 5. Negative 4 is 1. And then negative 2 is 1. And we're going to just start going back up. 0 is 5. And then 2 is 9. All right, so we've hit our spot, our highest spot on the graph. Now, if you want to know what your vertex is going to be, so that point on that V, you could just plug it in. You know it's going to be negative 3. and then just plug it in. And when you plug that into your calculator and your equation, it's going to be -1. And then just connect your dots. And remember, it goes on forever, so just draw the arrows. All right, bottom of that page. All right, so the 2 is going to stretch our graph. This 3 plus 3, so that's going to read opposite, it's going to move back 3. And then the -1 is going to cause it to move down 1 from the origin where it would start originally. All right, let's do our X and our Y's. And I have messed up on this. I actually sketched the last one on this one. But -10, -8, 6, 4, 2, 0, 2, 4, 6, 8, 10. Okay, so we had 13, and I'm going to go back. 9, 5, 1, 1, 5, 9, 13, 17, 21, 25. All right, I'm going to plot these points. So 9 at 6, -6, we have 5. At -4, we have 1. 2, we have 1. 0, 5, 2, 9. And remember, I said that if you plugged in that -3, that's what you're going to get. You're going to get the -1. So this is my graph, actually, for this one. If please write in pencil in these, and this is why, because I have all my work completed already, so I'm just copying what I have down. So that's what your graph should look like, okay? Because all I'm doing is I'm plugging that value into the calculator, and I'm getting the value. I'm plugging the -10 in for X. What do I get? The 13. And I'm going to take and do the same thing for -8. All the way down. All right. Now let's go back and we're going to regraph this one because I messed up. Sorry about that. All right. So when we plug this into the calculator, we're going to get 14. -8 minus 1 is -9. Absolute value of -9 is 9 plus 3. 9 plus 3 is 12. Then when we do 6, we get 10, 8, 6, 4, 4, 6. At 6, we get 8. And at 8, we get 10. Okay, now let's plot these points. We can't do this one because our graph doesn't go up to 14. Can't do this one because our graph doesn't go up to 12. -6, though, we can do. So -6 up to 10. -4 is 8. -2 is 6. 0 is 4. 2 is 4. 4 is 6. 6 is 8, and 8 is 10. And if you want to find out exactly what the vertex would be, we know it's going to be between, it's not going to be between these two anymore. It's where the number doubles back up. So right here, it's going to be between 0 and 2, which is 1. If you plug 1 in, you're going to get 3. You can usually tell. And then just connect your dots. And there you go. All right. As I said, sorry for my mishap. Let's go into page 12. All right. Again, you can see what each thing does, but that's just a repeat. So I'm just going to go ahead and we're going to do our x and our y values. And again, I'm still doing, you can do whatever values you want to do. You're going to have to pick these whenever you're doing your quizzes and your tests. But it's up to you. Okay? So, you can use the same ones that we use, or you can use different ones. All right. So when I plug these in, I get 9.5. All right. When I plug 8 in, I get 8.5. Now, I've noticed something right there. I don't want to have to be graphing in the middle of my boxes. So I'm going to change, and I did this on purpose. I'm going to change these. And I'm going to do odd numbers. Because if the even numbers are giving me halves, I want whole numbers because they're easier to graph. So -9, 7, 5, 3, -1, and then 1, 3, 5, 7, 9. Okay, now let's try and see if we can get a whole number. So if we plug -9 in, we're going to get 9. -7 is an 8. -5 is 7. -3 is 6. -1 is 5. 1 is 4. Then 3 is 5. 5 is 6. 7 is 7. 9 is 8. So we have whole numbers that we can work with. So let's plot these points. We don't want to deal with the half, so we're just going to let that one go. But -9 goes up to 9. -7 is 8. -5 is 7. -3 is 6. -1 is 5. 1 is 4. 3 is 5. 5 is 6. 7 is 7. And then 9 is 8. All right. So now we can sketch our graph. That goes that way. This one goes this way. And I know it's correct because it's not a negative out front, so I know that I'm sketching it correctly. All right. Bottom of page 12. All right, the first thing I noticed is there's a negative out front. So my graph is going to look like an upside down V. Okay? This is going to move it this way 5, and then this is going to cause it to move down 2. All right? Now, if we go ahead and sketch it, X and Y, -10. Let's see if we get whole numbers before we start. So if we plug in a -10, we're going to end up with a -7, so we are good. All right, so let's go ahead and fill in the 10. -8, -6, 4, 2, 0, 2, 4, 6, 8, and 10. All right, if you want to pause this and plug it into your calculator so you can get your values, go ahead. So we're going to get -5, -3, -3, -5, -7, -9, -11, -13, -15, -17. All right, so let's plot these points. -10 is -7. -8 is -5. -6 is -3. -4 is -3. -2 is -5. 0 is 7. 2 is 9. And then we can't graph anymore. Now we need a vertex, so we need that point, which is going to be between the two where it comes together the same for y. So it's going to be -5. So you plug -5 in, you're going to get -2. All right, so let's go ahead and sketch this. And there you go. Now, we were talking about transforming. I wanted to show you what this does. Now, our parent graph, remember, it was like this. Okay, that's what our parent graph looked like. But the first thing that we were talking about is going to move my vertex over to the left 5. So 1, 2, 3, 4, 5. So right here, it moved it over to this point right here. All right. It's also going to move it down 2. So 1, 2. Well, it moved it to this point right here. And not only that, this lets me know it's going to flip it upside down. And if you look, it is flipped upside down. So it done exactly what it was supposed to do. Okay? So that's how the transformations work with it. All right, page 13. We're going to go ahead and look at the characteristics of it. It's already graphed for us. So let's just look at the characteristics. So our x-intercept, where it crosses the x-axis, that's an order pair. So 1, 2, 3, 4, negative 4, 0. Where does it cross the y-axis? And you can guesstimate this. 1, 2, 3, 4, 5, 6, 7. I'm going to say 8. So 0, 8. If you put 7.5, that's fine. Now, your domain is going to always be all real numbers. Okay? Now, my vertex, and I want you to go ahead and write this down at the bottom because you're going to need to know this every time. But my vertex is where my V is, where the bottom of my V. And this one, it just happens to be negative 4, 0. Okay? Now, that's going to give me some information. For my range, my y value in my vertex is 0. So my range is going to be 0, and since my graph is going up, it's going to go to infinity. Okay? So this right here helps me with my range. All right. We're going to skip and go down to the end behavior. So is negative, or x approaches negative infinity. Y is, both sides are going up, so it's going to positive infinity. As x goes to infinity, y goes to infinity. Now, increasing and decreasing, it's been a while since we've done this. But remember, draw a line where it changes directions and put that value there for x. So that's a negative 4. All right, if we go this way, we're going to negative infinity. If we go this way, we're going to positive infinity. All right, so if we look at our graph from negative infinity to 4, is our graph going up or is it going down? We read it left to right, and it is going down. So we are decreasing from negative infinity to negative 4. All right, and then if we read it from negative 4 to infinity, going left to right, our graph is going up. So we are increasing from negative 4 to infinity. And you're going to have one of each anytime you have an absolute function. Okay? So the next one. Go ahead, grab vertex at the bottom. So vertex, and we'll see what that ordered pair is. It is right here. So 1, 2, we're going over. 1, 2, 3, 4. So 4, and we're going down. 1, 2, 3, 4. 4, negative 4. All right, so my y value in my vertex, the second one, so my range is going to be negative 4, and my ends are pointing up, so they're going to positive infinity. My domain, all real numbers. All right, now I'm crossing the y-axis. Right here's my y. All right, I'm crossing the y-axis right here, and that's my origin, so 0, 0. Crossing my x-axis, I've got 2 points where I'm crossing that x-axis, but that's okay. I can write them both down. So 0, 0, and then if you count over, 1, 2, 3, 4, 5, 6, 7, 8, negative 8, 0. Now, x is approaching negative infinity, x is approaching infinity. My ends are pointing up, so my y's are approaching infinity. Now again, let's draw that line where it changes direction. And that is going to be -4 for my, it's going to be -4 for my x value. Now if I go this way, I'm going to negative infinity. If I go this way, I'm going to positive infinity. So if I look at this, from negative infinity to 4, if I'm reading left to right, my graph is decreasing. So I am decreasing from negative infinity to -4. All right, if I look at -4 to infinity, my graph is going up as I read left to right. So -4 to infinity, I am increasing. And if you've conquered these characteristics, this should not be hard. You're just looking at a different type of graph. So this should come pretty easy to you. Now, I encourage you maybe to pause the video and go ahead and try the next 4 to see if you can get them, and then see if you get what I get, okay? All right, so the next one. Go ahead and write your vertex. It's right here. So 1, 2, 3, 4. 1, 2, 3. So 4, 3. Now, my range is 3, and I'm going up on both ends, so to infinity. My range are real numbers. Now, if I look at this, do I intersect the y or the x-axis? Remember, this is x, this is y. Now, I do not, so I have none for my x-intercept. My y-intercept, I'm crossing the y-axis about right there somewhere. So 1, 2, 3, 4, 5, 6, 7. So 0, 7. Okay? All right. Now, let's go ahead. Let's do our end behavior. So x goes to negative infinity and x goes to infinity. As x goes to negative infinity, it's continuing to go positive for y. As x goes to infinity, y is still going up in value, so it is positive infinity. All right. Go ahead and draw that line that we always talk about. And this is 4. We're going to negative infinity this way. We're going to positive infinity this way. So if we see and read this, and read left to right, my graph is going down. So we are decreasing from negative infinity to 4. And if we read this and read it that way, left to right, 4 to infinity, we are increasing. All right, next one. All right, our vertex. So vertex is going to be right here. So 1, and then we go down 1, 2, 3, 4, 5 to -5. All right, my range, my ends are going up, so it's -5 to infinity. My domain, all real. Where do I intersect the y-axis? About right here. So that's going to be 0, and I go down 1, 2, 3, to 0, -3. Where do I intersect the x-axis? Right here and right here. So -2.5, 0, and 1, 2, 3, 4.25, 0. If you put 4, I'll take that, either one. Okay. Now, as x goes to infinity and negative infinity, so as x goes this way, our values in y are going up, so they're going to infinity. As x goes to infinity, our y is going up, so it is going to infinity as well. Now, our end behavior, your x's are going to have a negative and a positive. Your y's are going to be the same thing every time. All right, let's draw that line right down through the center right here. And x is 1 at this point. We're going to go to negative infinity that way and then positive infinity this way. So if I'm reading this from negative infinity to 1, let me erase these arrows that we have up here right now. So I'm reading this left to right from negative infinity to 1, my graph is decreasing. So negative infinity to 1. If I'm reading 1 to infinity, left to right, it's going up, so I am increasing. All right, the next one. All right, so first thing I'm going to do, I'm going to find my vertex. Right here, my vertex, so I'm going over 1, 2, 3, 4, 5, 6. So negative 6. I'm going to go down 1, 2, 3, 4. Negative 4. All right, so my range, both ends are going down this time. So when they are going down, y is going to negative infinity. So my range is negative infinity to negative 4 because that's the highest point my y value gets right there. Okay. Now, my domain is all real. Do I intersect the x-axis? No. If this is the highest point that it gets, I'm not going to intersect it, so none. All right, my y-intercept, it doesn't show on my graph, so as I've said before, if it doesn't show on your graph, you can just go ahead and put in A. Do not put none because it does intersect it at some point, so just be careful doing that. But you can put NA if it doesn't cross on the graph you're given. All right, as x goes to negative infinity, x goes to negative infinity, so as x goes this way, y is going down, so it's going to negative infinity. As x goes to infinity, y is going down to infinity. All right, draw that line, and that x value is negative 6. So negative infinity to negative 6, and then to infinity. So if we look at these, negative infinity to negative 6, if I read left to right, my graph is going to go up at this point. So I'm increasing from negative infinity to negative 6. All right, if I read from negative 6 to infinity, my graph is going down. It's getting further from me. So from negative 6 to infinity, I am decreasing. All right, one more. All right, so our vertex. Our vertex is going to be right here, which is going to be 4, negative 6. So that makes our range negative 6 to infinity because it is pointing up.